Today, you're going to learn about central tendency, and I'll show you how to do a stem and leaf plot. But first, how about a riddle? What goes away when you call its name? Again, what goes away when you call its name? Silence. Get it? If you say silence, there's no more silence. Anyway, okay, let's start with the three different ways to find the center. That's why we say central tendency. That's the mean, median, and mode. The mean is also known as the average. You sum all the numbers and then divide by the number of numbers. For example, let's say you want to know the average of 3, 7, and 6. You would add those three numbers and divide by 3. So if we add those up, 16 divided by 3 is about 5.3 repeating. So that would be the average. The middle number, if you put numbers in order, then you can find the middle. For example, we have the numbers 1, 2, 7, 9, 11, and 15. That's 1, 2, 3, 4, 5, 6 numbers. Now, if there are two numbers in the middle, you find the average. The average of 7 and 9 is 8. So the median would be 8. But let's say we added another number on the list, and let's say we had 17 over here. 1, 2, 3, 4, 5, 6, 7 numbers, 3 on each half. 9 would be the median. Okay, that's how the median works. And for the mode, that's just the number that repeats the most. We say that's the most frequent. If there's a tie for most, we can say it's bimodal, but there's no such thing as trimodal or quasimodal. Quasimodal. Okay, if there's 3 or more that tie, we just say no mode. Let's do an example. Let's find the measures of central tendency for these ages of the Poly High School math teachers. Really, I didn't know their ages. I just guessed at how old they look. Okay, so if we have these numbers, by the way, let's see, there's 6 by 4, so that's 24 total. And then we add those ages up. I've added those numbers for you. All 24 of those numbers combined is 1,088. So grab a calculator, and we have 45.3 is the average age of the math teachers here at Poly High School. The symbol that's also used for average is kind of like an italicized X with a bar over top right there. The median, these are already in order for you. So what I've done, let's see, put them in order. There's 24. So that would be 12 numbers in the lower half, 12 in the upper half. So halfway between these two middle numbers, that would be the average of 42 and 43, which would be 42.5. The mode would be the most frequent. Let's see, 3 teachers are 36, so that would be the mode. The most teachers are 36 years old. To me, the mean or the median kind of show me the center best. I'd want to know the mode. Let's say I worked in a shoe store. What shoe size is sold the most? That might be popular or useful if I were going to order shoes or something like that. But for ages, not so much. Let's talk about how to do a stem and leaf plot. A stem and leaf plot is a useful way to organize data, usually as it's collected. And then you can split the numbers so that the last number is the leaf. For example, you have 857, you would split it here. 85 would be the stem and 7 would be the leaf. And I'll show you how this is useful. Example 2, a coin collector, and just kind of FYI, a coin collector is called a numismatist. This particular coin collector has Morgan silver dollars, and they were minted in the following years. Also, just another point of information, the first year they were minted was 1878, and 1904 was the last. And these were very pure, about 85% sterling silver, which is very high for a coin. So what we're going to do is we're going to split these numbers all right after the tens digit, but before the ones digit. And we're going to make a ranked, that means it's going to be in order, stem and leaf. So what I want to do is create a stem and a leaf. So I'm going to put stem here and leaf here. And I'm going to look at the first 3 numbers of my lowest and my highest. So my stems are going to go from 187 to 190. Never skip middle numbers. And the first and last have to be represented. Now I'm going to put the leaves on. You can separate them by commas, or you can just space them neatly. So the 8 represents 1878, and the 9 represents 1879. Now for the 1881, I'm going to put a 1 here. I got another 81, a 2, a 5, a 6, a 7, 7, 7, and 9. You see that 7, 7, 7, and 9. And now the 189 goes down on the next row. I have a 0, a 1, 3, 7, 8, 9, 9. And we know that all the numbers in the leaves are single digits. And notice I tried to space them out about the same, so that it almost kind of reminds you of a bar graph if you were to do that. They kind of look like bars if you look at it sideways. Also, let's finish this up. I need 1900, so that'll be a 0. I need a 3 and a 4. So here we can see for this coin collector that most of their coins were in this particular decade, the 1880s. So that's how you make a stem and leaf. What's really nice about a stem and leaf is it's fewer numbers. Like say you wanted to find the median. You could count here 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. So then I would say, oh, that's 10 numbers on each half. And I could easily count 3, 6, 9, 10. Okay, I can count 2, 3, 4, 5, 6, 7, 8, 9, 10. And that's my lower half. And boom, that 9 would represent the median. So that would be 1889. Oh, the year my great-grandmother was born. So hopefully you see how that might be useful. Even from here, if you wanted, you could start to make your box and whisker, which we discussed in the last lesson. And you could see those 5 important numbers that broke each quartile down. We put our median here, lowest number here, highest here, and our low hinge, which is our low median, and our upper hinge, which is our upper half median. If you want more information about that, you can go back to the last video, which is called Box and Whisker.